So what I'd like to do for ACE question number 22 on page 60 for samples and populations, investigation 3, just kind of give you an overview of how I solved this problem or how you might go about solving this particular problem. So you have this company that produces push pins and sells them in large boxes, and the secretary at the school opens the large box up and then just takes out 50 randomly and makes them into smaller boxes to give out to teachers. And these are the percents of each color that's in the large box. So 15% are white and 10% yellow and so on. So you would expect that when you reach into the box and grab out a handful of them that you would get them in about these percentages because you're kind of grabbing randomly and they're all placed in the box randomly. And so if you get a sort of a subset or a small sample out of the big box of these percentages, what would you expect to get? And so I'm going to kind of show you the first column of my table that I made for this problem. So if we had 50 in the little box and I would expect 15% of them to be white, what I did was I just went and I took 15% of 50, or 15.15 times 50, 15% of a number, so 15% of 50, and that's 7.5. And I just said 7 or 8 of them would be white. And I did the same with 10% of 50, and you may be able to do that without a calculator, just 1/10, or 50 divided by 10, or 0.10 times 50, there's your 10%. And then again, we have 5 that we would expect to be yellow. And then we've already done 15%, that's 7 or 8. 20% is twice as much as 10%, so that's 10 instead of 5. That would be orange. 15% already have done that, 7 or 8. And then the last one, 25%, which is 15% plus 10%, or 7 and 5 is 12, or 8 and 5 is 13. So that's how many, if you reach into a box of 50 and you were expecting these percentages to come out, you should expect to get about 7 or 8 of the white ones, 5 yellow, 7 or 8 red, 10 orange, 7 or 8. And the reason I don't put 7.5 down is because you can't really pull out a half of a push pin, and 12 or 13 of the blue ones, since 25% of them would be that. Now, the next part of this problem asks you to simulate that using the numbers 1 through 20. So what I did was I took the numbers 1 through 20 and then broke them down by the percentages. So if you take the number 20, 3 numbers is 15% of 20. I could actually do that here. If I took 15% of 20, that's 3 numbers. And then 10% of 20, put the decimal in there, 10% of 20, 0.10 is 10%, is 2 numbers. And so the numbers 4 and 5. So I took the first 3 numbers, 1, 2, 3, for white, 4 and 5 for yellow. We know 15% is the same, again, 3 numbers. 20% is twice as much as 10%, so 4 numbers, 9, 10, 11, and 12. And then, again, 15% is 3 numbers, 13, 14, 15, and really the rest, the other 5 numbers, are 1/4 of 20, are these numbers. And so what I did was, I said, okay, these numbers represent these different colors. So 16 through 20 represents blue. And on my calculator, I just did math, PRB, random integer, 1, 20, or 1 through 20. And so when I started pushing those in, then it actually picks numbers. So if it picked the number 9, then the number 9's in the orange set, so this would get a tally mark. And then when I push it again, the number 11 comes up. That's also in this one, so it would get a tally mark. And I did this 50 times. So there's 50 tally marks here. So in other words, I simulated what if I were pulling these out of the box, and how many of each color would I get if I did this. And my numbers came out 6, which is a little below that one, 4, a little below that one, 9, a little above, 12, a little high, 7 right at the bottom end, and 12 right at the bottom. So in other words, my simulation sort of confirmed what I know based on the percents that are in the box. If I randomly reach in there and grab them, I should get about these percentages out of the box. And sure enough, it's not exact. In fact, The reality is it'll probably never be exact because it's random, but it's close. And so random sample, or this particular sample, gives me a reasonable number that's close to what I would expect to get out of each box based on the percentages that are in each box.
Exactly.